Hello everyone, and welcome back to our show. I'm your host, ichino-ani, and it's so wonderful to be with you all today. Today is Monday, September 29, 2025. And oh boy, do we have a super interesting paper from the archives to talk about. It's a really neat one that helps us teach our AI friends to be even better helpers. The title is RLV, Binary Flexible Feedback to Bridge Between Human Feedback Verifiable Rewards. The curl is TATS RLHF or GAGSIV or CFAV 09.21319. That's a mouthful, isn't it? But don't worry, we'll break it down together. Okay, so everyone, let's think about how we teach large language models, like the AI you might chat with online. Right now, there are two main ways we do this, and they both have their own little problems. First, there's something called RLV, which stands for Reinforcement Learning with Human Feedback. This is like showing the AI 10 different answers and asking a person, which one do you like more, answer A or answer B? This is great because it can be used for almost any topic, from writing a poem to explaining science. The AI might not understand why you like to answer more, by thinking that longer answers are always better. This is a problem called reward hacking. And it means the AI isn't really learning to be helpful. It's just learning to trick the test. Then there's the second way called RLVR, or reinforcement learning of verifiable rewards. This is like a math test. Is the answer to 2 plus 2 equal to 4? It's a simple yes or no. This method is super clear and precise. Yet you see the problem, right? It only works for things that have a single correct answer, like math problems or simple coding tasks. It can't tell if an answer is creative, funny, or just polite, so its use is very, very limited. So here's the big question this paper is trying to solve. How can we get the best of both worlds? How can we have the wide-ranging usefulness of human feedback, but with the barista, clear precision of yes or no answer? And that's where this paper's amazing idea comes in. They call it RLV, Reinforcement Learning with Binary Flexible Feedback. It's a clever way to build a bridge between the other two methods, instead of just asking which answer isn't better. RLV teaches the AI by asking, does this answer follow a specific rule, or what they call a principle? And the answer is always a simple where yes and no. Yeah, no. So what are these principles? They can be anything we want them to be. For example, the principle could be, is the information accurate? Yes or no? Yes or no? Or even, and then does the answer avoid repeating itself? Yes or no? This is so cool, everyone. It combines the flexibility of human judgment with the clarity of a simple binary, yes or no choice. The AI gets very specific instructions on what to do better next time. It's not just be better, it's be more concise, or be more accurate. Now, let's think about how this could be used in our daily lives, where I have a few examples for you. First, imagine smarter and friendlier customer service chatbots. Right now, you might ask on about a question, and it gives you a super long answer that's technically correct, but really hard to understand. With RLV, a company could train its chatbot on specific principles. Principles like, be concise. Yes. Use simple language. Yes. And avoid technical jargon. Yes. This would make that bot so much more helpful and less frustrating to talk to. Here's another one. Personalized recommendations for you. Think about websites like Netflix or YouTube that suggest what to watch next. Usually, they just know if you like something or not. But with RLV, the system could learn why you liked it. You could even set your own principles. You could tell your movie app, I want movies that I want fast-paced taste. Yes, and have a surprise ending. Yes, yes. Or not scary. Yes. The AI could then find the perfect movie just for you, based on your unique tastes. Isn't that neat? And for my third example, let's think about AI assistants for creative people and programmers. If you're a programmer, you don't just want code that works. You want code that is efficient, easy to read, and has good comments. Using this new method, you could tell your AI coding assistant, always generate code that follows the principle of readability. Yes. And efficiency. Yes. AI would then act like an expert partner, giving you solutions that are not just correct, but are high quality and follow best practices. The researchers tested their idea, of course, and their models did incredibly well. They actually got the #1 spot on a big leaderboard called Catchbench. This proves their method really works. And the best part is, they made their entire recipe open source. That means everyone can use it to build better and smarter AI. They showed that their trained model could perform just as well as, or even better than, some of the very expensive, low-sorted models out there. But at less than 5% of the cost. That's like getting a super fancy race car for the price of a scooter. So to wrap it all up, this paper gives us a wonderful new tool for teaching AI. RL is a smart and simple idea that combines the best of other methods, making AI training more precise, more understandable, and more customizable to what we humans actually want. And that's our deep dive for today. It's just so exciting to see how we're learning to communicate better with our AI friends. Thank you all so much for listening, and I'll see you next time. Bye-bye.